Hello, engineering students. In this video lesson, you're going to learn about the International System of Units. The International System of Units, otherwise as SI, is a system of units, measurements consisting of 7 base units. You have the meter, kilogram, second, ampere, Kelvin, candela, and mole. This is the most widely system of measurement. Most of the world uses this measurement system. It is often referred to as the metric scale. Prefixes indicate an integer power of 10. And we can see the prefixes here, so deca, hecto, kilo, mega, giga, tera. You've definitely heard of mega and giga. Deca is to the power of 1, hecto is to the power of 2, mega is to the power of 6, and giga is to the power of 9. Note that the kilo prefix in kilogram indicates that a kilogram is 10 to the third, which equals 1,000 grams. So a kilogram is 1,000 grams. The fact that the kilogram is a base unit does not affect the meaning of the prefix, but allows for the use of the kilogram as a unit in the definition of derived units. Let's try to understand what we're talking about in this by comparing it to common objects. So, for example, the strand of human hair, we have it sectioned right here, is about 0.1 millimeters, in diameter. 2 sheets of paper stacked on top of each other is about 0.2 and that is also a good layer height for 3D printing if you want a very fine, detailed 3D print. So hopefully that kind of makes sense if you're a 3D printer in my class. The diameter of a paper clip is 0.8 So hopefully that helps to clear up or help you understand how these common objects are measured and how the metric scale is used to measure these. When you're recording measurements, be sure to always include units. So always include the units. So measurement always includes a value, so like the number, and the units, the the cm, the kilo, whatever it is. A measurement always involves a certain level of uncertainty. Measurement is never certain. There are always errors in measurements, even if they are very small. It is important to know the level of error that may be inherent in a measurement. A measurement is only useful if the value is associated with units and the uncertainty of the value is understood. There's no such thing as a perfect ruler, so there's going to be a little bit of uncertainty. So we'll do our best to measure as best as we can with the tools that we have. Scientists and engineers often use significant digits to indicate the uncertainty of measurement. Significant digits are digits in a decimal number that carry meaning indicating the certainty of the value. All digits you record for a measurement are considered significant. Include all certain digits in a measurement and one uncertain or estimated digit. Some general rules. Digital instruments, they read and record all digits, including zeros after the decimal point, exactly as displayed. Decimal scaled instruments record all digits that you can certainly determine from the scale markings and estimate one or more digit. We will concentrate on measuring and recording linear lengths in this presentation, but the techniques discussed apply to all types of measurement. And we're going to look at an example of a decimal scaled instrument first, the metric scale. So let's take a look at that. So here we have a metric scaled ruler. It's a typical metric scale. It includes the 30 plus centimeter graduated scale. And we should already know this. We should know that 1 centimeter is equal to 10 millimeters. Most of the rulers in our class will have the metric scale on one side. So just make note of that and understand that the one side that goes up to 30, that's the metric scale. And always remember that it's base 10, so 1 centimeter is 10 millimeters. 2 centimeters is 20 millimeters. 3 centimeters is 30, so you got 40, 50, 60, 70, 80, 90, 100, all the way to 300 or 300 millimeters or 30 centimeters. So if we zoom in on a metric scale, the millimeter is the smallest increment, and you can see that with the markings. the next largest marking should be 5 millimeters. And then the largest marking from 0 to 1 is going to be that 1 centimeter mark. These are the only marks that are actually numbered, the centimeter marks. So 1 centimeter, again, equals 10 millimeters. So let's look at this rectangle against a metric scale. How long is the rectangle? So this blue rectangle, go ahead and pause the video and count out to right at this marking right here. Okay, we're going to go ahead and zoom in a little closer so that you can see it. And look, it's a little bit past that marking. So you can tell that the length of the rectangle is between the 3 and the 4. And because the scale is incremented in millimeters, you can also be certain that the measurement is between 3.8 and 3.9. So between 3.8 and 3.9. So you're certain that the first digit after the decimal, the tens place, is definitely an 8. So this would be 3.8 centimeters. And because there's no tick marks between the two millimeter marks, you can only estimate to the hundredths place of the measurement. Perhaps you would estimate 3.83, 3.84. You know, you'll just take your best guess. For our purposes, we're going to say that this is 3.8. So remember the general rule. Decimal scaled instruments record all digits that you can certainly determine from the scale markings and estimate one more digit. So I'd be fine if you told me 3.8, but in reality, if you were like taking a test, you'd have to estimate to like 3.84, 3.83. So this is let me go back to that. So we certainly know that it's 3.8, and there's a level of uncertainty making it 3.84. Let's do this exercise one more time. So let's look at this rectangle. How long is the rectangle? If you said 6.3 centimeters, that's a very good estimate. If you said 6.32, 6.33, 6.34, those are also good estimates. Okay, now I'm going to hopefully have a worksheet for you with this video lesson, and you will then use the knowledge you just learned to measure these blue rectangles. And then once you are done with that worksheet, I want you to then draw these two objects on isometric paper. You can do each one on a separate sheet of isometric paper, and you're going to draw it to scale. So using millimeters, you will draw these blocks on isometric paper, and it should be accurately scaled as best as you can. So this is 80 millimeters. You should draw a line that's 80 millimeters, and so on. So that's our SI units lesson and activity. So you'll have a measurement activity and then this drawing practice.